My name is Ahmet Kerem Yumuşak from Bilkent University, and this is my 415 term project. In this project, I combined the op-amp circuit and bias circuit and made some tests such as noise test, stability test, and bandwidth test. In this part, we can see the schematic of my op-amp. As we can see, we have two symmetric transistor couples. These symmetric transistors are the two NMOS transistors in the lower end and the two PMOS transistors which are above the symmetric NMOS transistors. I separated my op-amp and bias circuit from the bias pin, which can be seen here. The width and length of all the transistors can be seen in this part as well. My bias circuit and width and length of its transistor can be seen here. The layout of my op-amp can be seen in this part. As we can see, I didn't have any net errors while routing the components. The layout of my bias circuit can be seen in this part as well. As we can see, I didn't have any net errors while routing the components. However, since Cadence didn't allow me to use rPoly-H, I used rPoly1, so that made the width of my layout very big. My schematic of one bias circuit and 4 op-amp, which is used to create a GDS2 file, can be seen here. The layout of 4 op-amp and one bias circuit can be seen in this part. As we can see, I didn't have any net errors while routing the components. Also, the width and height of the PR boundary can be seen here as well. Here we can see my test circuit for bandwidth. After we make a simulation, we can see the bandwidth of my circuit as follows. Our stability test and noise test circuit can be seen here. In this part, we can see our input and output noise signals. The signals are like what we desired, since we want the output signal to drop compared to the input signal. We can see the noise summary of our circuits here. As we can see, our phase margin is in the desired range, which is 50 to 60 decibels.